anytime, yeah, you can work with only one project to improve standard work, but you can keep in the database many projects. So when the projects with the minimum priority will be selected, for the exercise, because here the project A has the lowest priority, so therefore it will be picked up. So you can change the priority numbers and then refresh, and then the tool will appear, the project with minimum priority will be highlighted. So let me give an example here. For example, if I make it 0 and I refresh that, could you see that here, 0? So then if I click on the schedule button, then the standard work improvement will take place for this project. So let me restore it to 4 and refresh. So let me show you the data in this project A. Mm. So first, resources. In the resources in this project are one machine and two workers, operator and operator two, and two tools, tool one and tool two. These are the um, resources. But Yeah, but the type, the type 6 is assigned to the machines, and type 7 is assigned to workers, and resources other than machine and operators, they're assigned type 1. And select checkbox means if the checkbox is on for any resource, the machine, operator, or tool, then that will be considered for the scheduling. And if you uncheck any box, then the corresponding resource will be ignored. Yeah, it thinks that it's not available at all. The next calendar. Right now, I'm not implementing calendars at all because this is a standard work, a short time. So assuming that all resources will be available all the time, because this is a small operation, right? Standard work you're doing for one operation, not for the entire factory. And capacity, we assume that every operator can perform only one task at a time, and a machine can operate only one with one job, or you can perform only one operation on a machine at any time. The efficiency at the speed and the standard speeds we consider, so therefore we assign value 1. Suppose if I assign value 2, then it means this operator will finish his work, any operation, in half the time. So these two are used for what if analysis, and you might not need these groups, but in case, I don't know you would need or not, you could consider the groups of resources. For example, if the two operators are there, I can put one more, this operator two also I can put, and group here. So, and say here preference value 1, and validate mapping. I can save it if I want. Now, there's a group consisting of these two operators. So when I specify a group GR1 as a resource requirement, the tool has the freedom to pick any of these two, depending on the availability. So when you map the group as a resource requirement, our tool will pick one of the resources in the group and assigns it to that operation. So this is the information about resources at the work center where you would perform standard work improvement. Okay, now that's about resources. Let me talk about all these my simple tasks in that work for this project A. Here, the lower table on the right hand side, shows the list of all operations, individual tasks. These tasks are numbered as 10, 20, 30, and all. If you want, you could assign 1, 2, 3, and all, no problem. But I prefer with an increment because if necessary, I can insert some operations, into this table with assigning a different task number because we should not repeat the task number in the same project. And these are the durations, either seconds or minutes, you could take as you like. And predecessors, this shows in what order these are to be done. For example, task 20 is preceded by task 10, and task 70 preceded by 60 and 50, likewise. And it's not easy to understand the precedence relations among these tasks from this column. So for that purpose, we provide a network diagram. The corresponding network diagram can be seen through this window. So it looks like a zigzag one, and let me slightly rearrange this one here to make it more sensible. Okay. So when you rearrange, you have some clarity about it. And okay, this is not, it's not a perfect one, but basically this shows the precedence relations among the operations, at that work center. But it gives an idea of the dependency relations among, these tasks. Okay. Next, coming back to routing information, the next column contains the required resources. Task T1 requires only operator. Similarly, task T2 and T3 require only operator. Task T4 requires operator and machine. So likewise. So basically, what is done in improvement of standard work is when the machine is running without requirement of worker, the worker can do some other operations to save the time. That is the advantage I'm seeing in standard work improvement. So instead of worker sitting idle when the machine is running, during that time, he can take up some other tasks without violating the precedence relations. If you know the Toast Kaizen one, there also is the same thing. Okay, now you could ignore this column DS time right now. This is not relevant here for this application. Maybe I don't know why I kept it open. I don't recollect because we are not considering any dates or anything here. Okay, now if you want, you can save it as a template for future purpose. If you have some other project very similar to that, not exactly same, but similar to that, so you can save it as a template, to create new projects of this type in future. So, but there are a few templates, already. So later in the future, if you want to create a new project from the template, you could create it immediately and make necessary changes for the new project and start working with the project. That is the advantage of template projects, project templates. So now, if you want to change the for example, resources here, always you have an option, click that button and then assign the value. For example, here, if you want to machine also, for example, one machine, I put value 1. So it means that operation requires machine as well as operator. Or if you can also say from GR1, you need 2 resources. So it means this operation requires, for example, this operation requires 2 resources from the group. It means that, for example, you see here, it requires 2 operation resources from the group. So let me put it back, operator. Okay. So you can also now do one thing. Any assignment can also be seen in the top table. By clicking in the column header, when you click the column header, all the assigned resources will appear at the top. So it means one machine and one operator. Okay, whereas if you take this one, you see only only one operator required. So these are the resource requirements of tasks. So now, so there's an option here to renumber the task if necessary. If the precedence relations are not in the proper order, sometimes we see these numbering, not in a meaningful way, but correct, but not in a meaningful way, then you can renumber them so that it looks sensible. For example, the 70 is preceded by the numbers you see in this column will be less than that, so that you can understand the flow. Okay, that's a minor point. So now let us go for for this one to schedule all these tasks in the standard work. Let us go ahead and do. For the same data, you can also do assembly line balancing. But I want to do the standard work, the improvement. So therefore, I click on this schedule schedule standard work. So I did now. Schedule standard work. Okay. So this is the Gantt chart now for task schedules. So you see different colors here. The green segment represents an operation assigned to only worker. And the red bar represents an operation to be done only by machine. And the blue bar represents an operation that requires both machine and operator. And a hashed bar represents the walking time and the movement time between two tasks. So I have shown you so far before schedule generation. I have shown you two data items, that is resource information and task details. But I forgot to show you the movement times between tasks. I forgot, I'm showing you now. I should have shown you earlier. In this table, you can see the movement times. For example, if the worker has to go from task 40 to task 10, he takes 5 units of time. Similarly, if he has to go from task 80 to task 30, he takes 4 minutes. And here the zeros means it doesn't take any time. No time is required to go from 90 to 50. This I forgot this red color and the dark color. I think that, but yeah, this is a symmetric one. The 90 and no, to go from 80 to 30, it takes 4, but from 30 to 80, from 30 to 80 also it takes years, because when he's coming back, he takes the same time. But right now I can't recollect why the different colors are given for zeros. Zero means there is no time at all to move from one task to another task. So the times are given here. You can change these times in this table and save it for correction purpose, or temporarily save it for a what if analysis purpose. Okay, so those movement times are brought into this table. This I can say is a normalized form of that the table. Here, the two columns or three columns, so the predecessor task, successor task, and the time between them. The movement time. So now the top row in the Gantt chart shows it reveals some information. So you see that this yellow color, this yellow segment represents the time during which the operator is sitting idle. And again here, during this time, the operator is sitting idle. So when you move this mouse, you can also that in that time point, the corresponding time point in this box here. Okay, you can also zoom into that if you want, as much for more clarity if you want. Okay, so that hash bar in the top row represents that walking, the movement time. During that time, he's not doing any operation. So that's why the yellow color is selected for that. And he is moving. That's why the hash sign is there. And the green segments represent the operations to be done by the operator. Even if the two operators are there, their operations will be shown on the same. They may even overlap. But here in this case, I think we are considering only one operator. So this is the Gantt chart. There is no optimization, nothing. Simply all these tasks are scheduled without violating precedence relations. So this is a simple schedule of these 14 tasks. Now we can improve. We can improve by manual also. We can drag them. For example, so during this time, this what we can do. For example, this operation. Let me put this where 1 second. The predecessors. This shows in the precedence relations. During this time, because these two are unrelated, T3 and T5 are unrelated, so I can schedule during this time. For example, I can drag it. So now I reduce the total make span from 148 to 131. So let me go back. I undid that. So what I did in this operation, I moved this T3 during the machining time. Because these two are not related, so that's the freedom to move it. In fact, I can move it until this one, until this starts, this is a T3 is preceding only this task. So I have a lot of freedom to move it anywhere, as I like, anywhere I can do that. Oh, it's not coming that much. Okay, it did. Let me put it back. Only when I moved up to this, I saved only 6, time units. So similar, you can this is what people do normally, manual standard work improvement. They try to, they observe and they try to, move some operations on the time scale for improving the standard work. So that's what I've been doing now here. And here also one more thing, maybe it is not working well. It says and it cannot, it will violate. And so what about this one? Can I do that? Yes, it did. Here I reduced by 13. It's still better. So instead of pulling this T3 to this around this time, if I pull T2, then I'm getting slightly better result. So let me put it back. So one can do like that manually and improve to some extent. But you can also do you can also use the heuristic to improve. Let me do that now. I restored it. So I ran the heuristic for 14 tasks. It takes almost no time. And how much I improved now? I brought it to 114. Remember earlier is 148. From 148 make span, I brought it to make span 112. It's a big deal, you know. This much better than what people do manually, in lean manufacturing. And now on the top of this, we can optimize. This optimization is based on implicit enumeration. This is algorithm, but implicit enumeration. So it takes time. For example, I don't recommend this for more than 20 tasks, the implicit enumeration, because it will take more time. But here I think it will take a few seconds for 14 tasks. For any standard work consisting of 14, 15 tasks, it won't take much time. So on the top of this, I want to optimize to see can I get something better. So I got still better, 106. This is the best. So you cannot perform these 14 tasks subject to all these constraints for less than 106 time units. So this is the optimal schedule. So the worker has to do this at T1 first, and then next you should perform T2 and set this machine operation. Um, After that, you will be walking, for this T2. From T4 to T2, there is from 40 to so let us see, from 40 to 24, 4 minutes. So the 4 units of time to reach T2, then he will be working here. Then from here you go to T6. There is T2 to T6, 20 to 60, 5 units. So he will take 5 units of time to reach T6. Then he will be working for a while. Based on how long is determined by the task duration. And then he is walking again to T7 to 60 to 70 again, for 4 units of time, and likewise this is so you could see in what order he is performing the operations. Hmm. And you can also see the critical ones, show the changes, and there should be an option somewhere to see the critical tasks, cycle time changes, time on chart. Oh, here maybe. So this shows the critical ones. So if you want to reduce the make span further, you have to reduce the durations of one of them. In this schedule, this is like a project, with tasks, the dependency relations, and resource requirements. This is a tiny project. These are the critical tasks in this tiny project, and you can see that this machine operation T8 is not a critical task. Similarly, T13 machine operation is not a critical task, but T5, there is also machine operation. That is a critical task. Out of three machine operations, one of them happens to be on the critical um, path, right? So this is what I wanted to show you. And if you look at the output, now you can see in the numerical format, what time to what time. Each operation, this is a detailed schedule. And resource utilizations can be seen. How many hours the make span is 106. Out of that, operator is scheduled for 63 units of time. Machine is scheduled for 73. You can see the percentage utilization, right? And you can also see now resource chart. Here you could see the schedules of resources. We put the machine operations, the red color that you see, and the blue colors represent operations which require both machine and operator. And yeah, the green one is the operation that requires only the operator. So here you can see the machine is sitting idle during this time, right? But worker is not sitting idle at all. The same thing you can see in the Gantt chart also. Here there is no idle time for the worker, during the entire make span. So we compressed it so that he doesn't waste a single unit of time. Okay. You have any questions now? So basically what I've shown you, the input and the output. And you could do manual operations, by drag and drop. You can do anything. You can all feasible drag and drops can be implemented, whether it's good for for better or worse. But it allows all feasible drags. But I don't think bringing forward. I don't think that you can bring some operation forward. Always you can push them on, into the future in the drag and drop operations. So yeah, this is what I wanted to say today. So then after you do manual operations, I see how much you're improving. And if you run this heuristic, you go back to the original data and run heuristic and see what improvement you will get. On the top of that, how much improvement you would further get, you click this button to see further improvement beyond the heuristic. Yeah. So I don't remember these M1 and M2, these two methods because 2, 3 years ago this was developed. After that, I didn't look into that. But you can keep M1. There is no harm. I don't remember fully that what M2 represents, but it is also method. I don't know, forward, backward, I don't remember. So after you make all this a refresh, I think they're refreshing in this table. You can see the network here in this chart and stuff. You can also network there. You get the same network, but here also you can see, that critical tasks. All the ones in the orange color are critical tasks, and these two are not on the critical path. The blue ones, basically, that two those are machines here, operations. Okay, now thought save. These are not serious. I don't remember the sort what it means. The movable tasks. So these are the movable tasks. These, if you want to move, these are five no predecessors, non-predecessors, all predecessors. So let me look into the network diagram here. 50, that is 2 and 3, 20 and 30. Yeah, if you want to move, I know these 2 and 3 will not have any objection. They allow. Similarly, if you want to move 8, you can, these two will not create any problem. But if you want to move this task, the 10 and 20, they will create a problem. If you want to move 5, where is the 1? Yeah, these are tied up, mainly connected. This the 1 and 4, 1 and 4 precede 5, as you see here. 5 means 50. 1 and 4 means 10 and 40. They precede. Similarly, 8 preceded by 5 operation. 1, 4, 5, 6, 7. Where is 8? 8 is here. That is preceded by 70, 60, and these two. These three and these two are the predecessors of 80. That's why you see all of them. Here, basically listing all predecessors, either direct or indirect. All predecessors of tasks are shown here. Okay. Mainly that's for information purpose. So this is what I can say quickly. So if you want to create a project, what you could do, uh, go here. I don't know whether create a new project. I think this creating a new project is the empty table it gives. You could enter all the information here and give a project ID and save it, so that you're going to save one more project. But if you want to analyze that, you have to assign the least priority to the new project which you are going to create. Or you can do it, take any project, you can edit this one. If you want, you can add some rows, insert some rows, delete rows, and may make any changes, for the new project, so that you can create a new project. So you can create one project, a new project from one of the existing ones in this fashion, or get a clean table, empty table, and fill in all the information for the new project, and create it that way. These two are, you have one more. You can also create from the template. If you have the templates, recall the template and assign a project ID. Yeah, I think maybe I'm explaining too much about project creation. But if you want to create a new project, you could use any of these options. I don't know how many tasks you have, no idea in that one. So now you have any questions about for this? I think I explained to you input and how to generate a schedule and how to improve. Okay. So let me know if you have any questions. Avinash?
Sir, what if there are like multiple resources involved? Like here you used only operator and machine, but
Yeah.
what if there are multiple resources like tools and
Yes.
like other like more resources involved? How do we solve?
So tell me one example for which of these tasks require a tool I will implement. Select anything randomly as you like.
7 or 8? 7.
7, okay. Go here to the routing information, T7. I will include it to a tool also. So tool 1, for example, I'm putting, right? Um, I want to do one thing before doing that. Let me do what I will do. I go to the resources and I will create another group, say tool. Then see where the tool is particularly with ID, but you can write whatever you want in the group description. And by default, the type is 1. This is not a bottleneck. Forget about the last column, bottleneck column, and save it. Now I come to this one. So tool and tool 1, I'm mapping tool 1 and preference value 1 by default, and 1 tool. I'm mapping tool 1 and tool 2, right? And validate. So initially they appear in the red color. When you validate, it will check whether the elements in this table are recognized. All the elements in this group ID column must belong to this table, and any entry in this column must appear in the lower table. Otherwise, you will see in the red color. So let me save this now. Okay, what I did basically, I created another group called tool, and I mapped tool 1 and tool 2 to that group. So now I assign, instead of saying tool 1 or tool 2, to 7 here, I will assign the group, tool group. Okay. I will assign. Now you see, I added this one, right? Tool. So let us see. Our tool will pick one of the two tools. There are two are there. Let me save it temporarily and reschedule it. Now, if you look at this, machine operator tool 1, it picked up tool 1. And one more example I will show you. For example, T8 also requires tool. Let us see what happens. T8 also requires a tool. I can simply put by hand, no problem. 8 also requires a tool. Let me save it temporarily and schedule it. Now, because these two do not overlap, it is putting the same one. But I can do manually if I can change it. For example, here I can make it a tool 2. Um, tool 2 directly I'm missing. This requires tool 2. Then let us see the assignment here. So the T7 requires tool 2, whereas T8, can be done using tool 1. I'm just making small changes in the assignments, right, to demonstrate. So you can assign machines, workers, and tools also. The tool, a jig, a room, whatever it is. But those are they have that type 1, you know, because we implement there's some logic for operator, because we want to optimize with operator, the operations done by operator. So that's why a type 7 is assigned. So there is a specific reason why these are assigned. But here you assign 1 or 2 or 3, doesn't matter. But as long as you don't assign 6 or 7 here, no problem. But the 6 has a meaning and 7 has a meaning in this tool. But all other numbers effectively are the same. So I demonstrated to you that you can assign, you can specify requirement of machine, operator, tool, jig, room, and all. Okay, are you convinced now?
Oh, yes, sir.
So any other
So,
question? Yeah.
so this works for if we have like 50 tasks.
Yeah, the 50 tasks, it will work first of all, even if you have 100 tasks, it will work like this initially. But if you run heuristic, it won't take much time, less than a minute. But as I tell, optimization, not more than 20.
Okay, sir.
So the limit comes mainly for optimization, the exact optimization,
Okay.
because this is a highly combinatorial, this problem. Hmm? And note that we are also concerned not only the resource constrained project scheduling, but we are also considering the travel times, right? So in project schedules, you don't see the travel times. In a typical project scheduling, travel times are not considered between tasks.
Yes, sir.
But here we're considering that also. So therefore, assume that yeah. So one way it involves trial and salesman problem also. In what sequence he has to go. Suppose, assume hypothetically, no machines are required at all, and all operations can be done in any order. Are you following me? Suppose no machine is required for any operation, all operations can be done in any order, but there is some time to go from one operation to another operation. Then is a typical traveling salesman problem, right? There
Yes,
is a
sir.
special case of this. There is a special case of this. So in such a case, I know example is remove all this predecessor column and remove the machine requirement, keep only operator, and put this travel times. Then there's a traveling salesman problem, right?
Yes, sir.
So in this example, in this kind of examples, what we need to do is we have to remove this idle time of the workers in the make span. That is the objective. So that you compress the make span, so that you get more productivity.
Yes, sir. Thank you.
Yeah.